Okay, good afternoon, guys. Am I audible? So anyone respond, please?
Yes, sir.
Okay, right. Thank you. So we are in the second module, and in the previous class, we discussed about the network topology. So definitions of graph, tree, and how to form the incidence matrix. Okay, so today we are going to discuss about the basic Cutset and Triset matrices for planar networks. With this, we are going to conclude the second module. So first, see the Triset matrix. Right. Suppose if you are given a network, so from the network, so the network in the sense electrical network, right? If you are given an electrical network, you can draw the graph. How you can draw the graph? All the passive elements will be replaced by line segment. Voltage sources will be short circuited and current sources will be open circuited. Okay. So from the electrical network, you will draw the graph. So let us take for example. So this is a graph of an electrical network. Okay. So now from this graph, how you can select the tree? So that also we already discussed. How we can what is a tree? So a tree is nothing but it is a subgraph of the original graph, which is having all the nodes of the graph. So but no closed loop. Okay. So now from this graph, you can extract many trees. Okay. So arbitrarily here we are selecting one tree, so which is having 4, 5, 6 branches. Right. So if you observe this this tree here, so which is in the second picture. So in this tree, you are having all the nodes of the original graph A, B, C, D, but here you are not having any closed loop. Okay. So now this is a tree. Okay. Right. So now from the tree only, we are going to develop this Triset matrix. Suppose after getting this tree, if you add one link to this, so you can get a closed loop, right? So addition of each link between any two nodes, so forms a loop, so which is called the fundamental loop here. Okay. So from the graph, first you have to draw the tree, right? So tree is nothing but it is having all the nodes and without having any closed loop, right? So with 4, 5, 6, we were formed this tree, right? On remaining elements 1, 2, and 3. So this 1, 2, 3. So with this you can form the core tree, right? So the elements 2 and 2, 3 and 1, 1, 2, 3. These all 1, 2, 3 are called the links here. Okay. I will just okay, ma'am. So from this graph, we developed one tree. Now here we were removing some of the branches here. Okay, so these are the branches. So which are 1, 2, 3. Okay, so now with 4, 5, and 6, we formed a tree. Now this branches 1, 2, 3 will become a core tree. Okay, and the branches of core tree are called the links here. Okay. So the links is these are the links. 1 is a link, 2 is a link, 3 is a link. And branches of tree are called the twigs. So here this is a twig here. Okay. So this is a twig here. 4, 5, 6, 4, 5, and 6. These are the twigs. Right. So now for a given graph, so for a given tree of a graph, suppose if you add a link between any two nodes, now it forms a closed loop. Okay. So from this tree, if you add a link here, that link is 1. So link 1. So if you add this, now you are getting one closed loop here. Right. Suppose if you add another link between these two nodes, you are getting another loop here. And if you are adding another link, third link also, link 3. So here also you will get the another loop. Now each of these loops are called the fundamental loop. Okay, so now in a loop there exists a closed path and a circulating current. So now here, when there is a closed path, now you can represent one circulating current here. So let it be I1, it may be I2, and it may be I3, like that. Okay, so there exists a circulating current. Now this current, now here it is called the link current. Okay, so now this current is this link current is the loop current, not the branch current. All right, so this is the loop current. So in this loop, okay, so in this loop you are having the another current I2. In this loop you are having the another current I3. So branch current is nothing but this is the current flowing through each branch. Okay, here we are already selected the direction for this. Okay, which is a oriented graph, right? So now the current flowing through each branch is called the branch current. Now here, after forming a loop, the current flowing inside that loop, we call it as a loop current, or here we are calling that loop current to be a link current. Okay, now the current in each branch of the graph can be found by using this link currents only. Okay, so the current in each branch, so now you can determine from these link currents, and the fundamental loop is formed by one link which has the unique path in the tree and joining the two nodes of the link. So fundamental, how we can form the fundamental loop? So by joining two nodes. Okay, so by joining the two nodes with one link, right? So that loop is called the fundamental loop, and this is also called as F loop or Triset. Okay, so now, so the loop so formed by with this link and these two twigs. So this loop is called one fundamental loop or one Triset. That means 1, 5, 6. With 1, 5, 6 elements, you are forming a one Triset. So like that, you are having 3 Trisets here. Okay. Okay, right now. So now here, consider a graph which is connected, which is this one, and this graph is having 4 nodes and 6 branches. So nodes are represented with A, B, C, and D. So there are 4 nodes, and branches are represented with numbers 1, 2, 3, 4, 5, and 6. Right. So in this graph, you are having total number of nodes will be 4, and total number of branches will be 6. Okay. So now, from this graph, you have to select a one tree, right? So from this graph, you can have the many trees, but any tree you can select. Okay. So now I'm selecting a tree with branches 4, 5, and 6. Right. So now these branches of your tree is called the twigs. Okay. Now how many branches you have in a tree? In a tree, how many branches you have? N minus 1. In the last class, we already told this. Right. If you are having n nodes, then minus 1 will become the number of branches in a tree. So the total number of branches which are called the twigs here will be equal to n minus 1, as there are n 4 nodes here. So 4 minus 1 will become 3. So 3 are the twigs or branches of a tree, and the remaining branches are called the links here. So number of links in this tree will be L is equal to total number of branches in this tree minus total number of twigs. So 6 minus 3 will be 3. Okay. So now here, remember that this 4, 5, 6 branches here is the branches of a tree which are called the twigs, and the removed branches 1, 2, and 3. So these branches are called the branches of your core tree. So you can call them as a links. Okay. So now if you join one link to a tree here, suppose here between two nodes, if you add one link, so then you get a loop. That loop is called the fundamental loop or F loop or Triset. So Triset is the set of branches with 1, 5, 6. You are having one loop. So this is one set of Triset. Like that, here in this, you are having total number of links as 3 here. So basically, you will be having 3 number of Triset loops or fundamental loops. Okay. So how many links are there? Those many fundamental loops will be there in a given graph. Okay. Right. Now see here. So now let us assume that I1, I2 up to I6 will be the current flowing through each branch. Okay. So current flowing through branch 1 will be I1. Current flowing through branch 2 will be I2. Current flowing through branch 3 is I3. Current flowing through branch 4 is I4. Branch 5 is I5. Current in branch 6 is I6. Okay. So like that you have to assume. Okay. Let us assume that I1 to I6 will be the branch currents with the directions which are shown in the figure here. So here we were represented the directions also. Okay. Right. Now here let us add a link to its proper place. So to a tree. Now, so from this graph, you select one tree here. So with the 4, 5, 6. Now 1, 2, and 3. So these are the links, right? As I said before, these 4, 5, 6 are the twigs, and 1, 2, 3 are the links. Now we are adding one link to one link between two nodes. Okay, so see here in the figure C. Okay, here between A and B nodes, we are adding link 1, so that we are getting one loop here. Okay, so now let us call this loop current to be I1. Okay, so like that you are having another link 2 with 2, you replace here in the same position of its branch. Now here you are getting another loop, which is fundamental loop. So now let us assume that the current flowing through this loop is I2. So now with link 3, suppose if you join the link 3 between C and D here, now you are getting another loop, and let us assume that current flowing through this is I3 here. Okay. So now after adding the link, so there is a formation of link current. Okay. So link current, or you can call it as loop current, right? So in each loop, we are calling them as a I1, I2, and I3. Okay. Now how you can assign this direction for the loop current? So here the direction of loop current I1, how you can choose? So generally by convention, you have to choose the direction of loop current I1 to be same as the direction of current in the link. Yes. Any doubt now? Okay. Right. Here in each loop, after connecting a link here, every time there is a formation of loop, so which is called the fundamental loop. Now in that loop, we are assuming loop currents I1, I2, I3. Now what is the direction? That direction will be given by the link current. Okay. So now you are adding the link current. That the link current will be from A to B here. So in this loop, the current also in the same direction. Okay. So in link 2 here, this is the direction. So that the current will be in this direction. On link 3 also the same in downward direction. So current will be in this direction. Okay. So you have to choose the direction of current will be same as the link current. Okay. So now here a triset can also be defined as a set of branches, so that forms a closed loop in which the link current will flows. Now by adding the other link 2 and 3, you can form the two fundamental loops, which are called the F loops. with the link currents I2, I3 respectively. So which are shown in all these figures. Okay. Right. Now you have to develop the Triset matrix. Okay. See here, to develop the Triset matrix, you have to apply the Kirchhoff's voltage law. Okay, in each fundamental loop. So to get a linearly independent equations. Okay, in each loop you have to apply the KVL. Okay, as there are 3 loops are there. So with loop currents I1, I2, and I3, and link branches here is 1, 2, 3. So 1, 2, 3 are the link branches. Okay. So now here also you assume that V1 to V6 will be the branch voltages. Okay. So current flowing through each branch we are assumed before it is I1, and let us also assume that current voltage across this branch will be V1. So like that you are having a total of 6 branches. So V1 to V6, these will be the branch voltages. Okay. So here in 1 we will be having V1. So in 5 V5, here V6. Okay. So direction of voltage will be depending upon the current flowing through that branch. Okay. Now see here, you apply the KVL in this loop. Here you have the V1, here you have the V2, here you have the V3. Now how you can assign the plus and minus sign according to the direction. Now in this direction, so this will be plus, this will be minus. Now it is downward direction, so it is plus, it is minus. Now here in this direction, so this is here plus, here minus. Now you apply the KVL. So according to KVL, so minus to plus you can write it as positive. So plus V3. So then here plus to minus, so minus V1. So now here minus plus to minus again minus V2 is equal to, sorry, V5, this one. Okay, so this is V3 and this is V1, this is V5. So current of voltage across the branch 5. Okay, so you are getting this equation. Okay, so they are taking in opposite direction. Plus to minus they are taking it as positive. Sorry, this V3 not V3, it's V6 kada, V6 here. V6, V1, V5. Okay, so they are, instead of taking minus to plus as positive, even you can take it as negative. Minus to plus you take it as negative, so then it will become minus V6. So plus to minus positive you take, this will be plus V1 and plus V5 is equal to 0. You can take anything now. So now this will be your equation here. So V1 plus V5 minus V6. Okay, so while writing this loop equation, they assumed that when the direction is from minus to plus, the voltage will be positive, sorry, negative. And when it is plus to minus, then they are taking it as negative, sorry, positive. Okay, like that they are developed in each loop. Okay, so here this loop current I2 is going through 2, 4, and 5. Okay, 2, 4, and 5. Some current, if you observe, this is in the direction, this is in this direction, and this is in this direction. So here V2 will be there. Here in 4th branch V4 will be there. In 5th branch V5 will be there. Right. So top to bottom direction is there. So it is plus, it is minus. Now here it is plus, it is minus. Here it is plus, it is minus. Now apply the KCL. Sorry, KVL. Okay, again you apply the KVL and write the another equation. Okay, so minus to plus they are taking it as minus. So minus V5 plus, so plus to minus V2 plus you have to consider plus V2 plus to minus again plus V4 is equal to 0. So that means this you can write as V2 plus V4 minus V5. Okay, V2 plus V4 minus V5 is equal to 0. Okay, so this equation is for loop 1, and this equation for loop 2, and this is the equation for loop 3. Right, in loop 3 we are having the 2 elements only, 3 and 4. So the direction will be in this direction, this is also in this direction. So V3 here and V4 here will be there. So it is plus minus, and here plus minus. Okay, if you take here, so plus to minus, this time minus to plus. So V3 minus V4 you will get. Okay, So for each loop, you will get a one equation. Okay. So as you are having three loops, you are getting three equations here. Okay. So by applying the KVL, so KVL in each fundamental loop, you are getting one equation in each loop. So total there are three links are there. Okay. When you add each link, you will get one loop. As there are three links, there will be three loops. As there are three loops, it forms the three equations, independent equation. Now these equations you can represent in a matrix form. Okay. So how you can represent this in matrix form? So like this. Okay. The above equation can be written in matrix form as like this. Okay. So here we are taking, so the voltages are from, so from V1 to V6. Okay. So those voltage vector we are representing in a matrix form, column vector V1, V2, V3, V4, V5, V6, all the branch voltages here. Okay. So in this side, you are getting 0 here. Now here you will get a matrix here. Okay. So that matrix, so here V1 you are having 1, V2 is not there, so 0, V3 is not there, 0, V4 is not there, 0, V5 plus 1, then V6 minus 1. So like that you have to write the equations. Okay, for V2, so for the second equation, V1 is 0, V2 is 1, V3 is 0, V4 is 1, V5 is minus 1, V6 is again 0. Now in the last equation, you have only V3 and V4. So for 3, you will get plus 1. For 4, you will get minus 1. So remaining will be zeros. Okay. So now this matrix is called the Triset matrix. Okay. So the Triset matrix is represented with letter B. Okay. Now, so this vector is a branch voltage vector. So you can write it as VB, which is equal to 0. Okay. So now if you see here, this branch, this vector Triset matrix is having how many rows? 1, 2, 3. So these rows will be same as the your links here. Okay. Or link current you can represent. So here this you can represent them as a link currents. And this side columns will be branches 1, 2, 3, 4, 5, 6. Okay. So the order of this Triset matrix will be link currents. How many link currents are there? That L by total number of branches B. So L by B is the order of this Triset matrix. Okay. See here. Okay. So the rows are your loop currents. So on columns are your branch currents, you can say. So finally you are writing B into VB is equal to 0. And this B is a Triset matrix. And VB is a column vector of branches, branch voltages. And the order of this B will be generally L by B. So L here is nothing but link currents or loop currents, you can say. And B is the number of branches. Okay. So L by B is the order of the matrix. So which is called the Triset matrix. So this Triset matrix we can also call as a fundamental loop matrix. Why? Because you are getting this matrix from the fundamental loops only. And VB is a column vector, so which is having the all branch voltages. Okay. So now, so B is having some elements here. Okay. So let us call each element to be equal to Ij. I represents the rows. J represents the column. Okay. What is the row here? So rows are the currents here. So loop currents. And column is a branches here. Okay. So now here I is the current, loop current or loop current. So B is the, so this J is the branch. Right. Now the value of Aij will be equal to 1 if the branch J is in the loop So in the fundamental loop I, and their direction will be coincide. Okay, so see here in the previous slide. So instead of writing these voltage equations, you can directly write the matrix here. Okay, how you can write? So you have to remember these conditions. Right, the element in the matrix, Triset matrix B will be like this. So Bij will be equal to 1 when the branch is in the fundamental loop and the reference direction will be coinciding. And Bij will be equal to -1 when the branch is in fundamental loop and their reference direction are opposite. Okay, and Bij will be 0 when the branch is not there in the fundamental loop. Right. So if you see here, so this is the first fundamental loop. Okay, so this is the first fundamental loop. Here we are having the elements 1, 5, and 6, and this is the loop current. Okay, so now if the branch current and loop current, if both are same, you will get a +1. Okay, for 1 you will get +1. For 5, so 5 also in downward direction, so here also 1. So, but for 6 it is in this direction and I1 is in opposite direction. So for 6 you will get -1, right? So you can write the current. Show the matrix, see the matrix here. So you are having here you are having 1. So for branch 1 +1, and branch 5 it is +1, for branch 6 -1. Okay, so next it is the same again. You take another loop here. See here, so second loop. Okay, so in the second loop, what you are having? You are having element 2, 4, and 5. So remaining elements are not there in this loop. So those values will be 0. Now if you observe the direction here, so 2 is in this direction, 4 is in this direction, 5 is in this direction. Now the loop current and these branch currents, if you see, 2, 4 will be having the same direction as your loop current, but 5 is opposite direction. So for 2, 4 you will get +1. For 5 you will get -1. Okay, so like that in this loop you are having only 3 and 4, right? So 3 is in this direction, 4 is in this direction. So this 3 is in same direction as your I3, so, but 4 is opposite direction. So 3 for 3 and 4, for 3 +1, for 4 -1. Okay, so see here, so 1, 1, -1 for 2, 4, 5, 3, 4, it is 1, -1. So for two loops I have written directly. Okay, so now if you observe in the matrix, you can see the same. Okay, see here, for 2 it is +1, for 3 for 4 +1, for 5 it is -1. For last loop you are having only 3 and 4 elements. For 3 it is +1, for 4 it is -1, like that. Okay, you can directly write this Triset matrix from the given graph. Okay, all right. So you have to remember this one. So these conditions. So the value of element in the Triset matrix. So Bij will be equal to 1 when the branch current and the loop current both are in the same direction. So it will be -1 if the branch current and fundamental loop current both are in the opposite direction. Okay, so on the branch Bij will be 0 when the branch is not there in the loop. Okay, so now after getting the Triset matrix, you can represent a relationship between the Triset matrix and branch current also. Okay, so in previous slide we represented the relation between your Triset matrix and branch voltages, right? So Triset matrix branch voltage relation is this one, VB is equal to 0. Okay, so this is the relation between Triset matrix B and branch voltages. So similarly, so between Triset matrix B and branch currents also you can develop one equation along with the link currents. Okay, link currents is nothing but these loop currents. Okay, so branch current are the current flowing through each branch, which are small I1, I2, I3 up to I6. 6 branches are there, those 6. Now this is B is the Triset matrix, which is this one, right? How you can form this Triset matrix? you already know. Okay, see the relation now. Okay, so between Triset matrix and branch currents. Okay, it is possible to express the branch currents as a linear combination of your link currents. So by using this Triset matrix B. Okay, how you can represent? So let us see. So the branch currents, if you observe here in this graph, okay, in this graph we are representing all the branch currents. These are the branch currents direction. Along with the loop currents also, they here we are mentioned. Okay, so now this branch current I1, small I1, so is will be in the same direction as your loop current I1. So I1 is equal to I1, you can write. Okay, and for second branch current I2 is in the same direction as I2. So I2 will be capital I2. And if you take the branch 3, then the direction of current through branch 3 will be same as the loop current I3. So I3 in place of I3, you can write capital I3 also. Right? If you observe this branch 4, right? So this in this branch 4, we are having two currents, right? Actual branch current is this one. So this current will be, so if you represent with loop currents, this is in this direction, and I2 is in this direction. So I2 minus I3 will be your small I4. Okay, small I4 is equal to I2 minus I3. Okay, similarly for I5 will be, so I1 is coming in this way, I2 is in opposite direction. So I1 minus I2 is what? I5. So I6, if you see, current is in this way. For this, in opposite direction, you are having I1, capital I1. So small I6 will be equal to minus I1. Okay, like this, you can represent the branch currents in terms of loop currents like this. Okay, so loop currents, or you can also call them as a link currents. Okay, this capital I1, capital I2, capital I3 are the link currents. Now all these you can represent in the matrix form. Okay, how you can represent? Sorry, this is not correct. Right, so how you can represent this in matrix form? Again, you have to write the current vector I1, I2. Right, okay, correct one. Right, so here I1, I2, I3 up to I6 you are to have. So same, it is correct only. Right, I1, I2, I3, I4, I5, I6. So we are representing all the branch current as a one column vector. Okay, now this side all are represented with link current. Okay, so this link current we are forming with one column vector. Okay, I1, I2, I3. So now here this I1 is equal to only capital I1. So here you will be having 1, remaining 2 you will be 0. Okay, so now if you write this, I1 is equal to capital I1 plus 0 I2 plus 0 I3. Same, you will get this equation only. Okay, so now these all equation we are representing them in a matrix form like this. Now here, if you see this one, okay, so this one, so this is equal to transpose. Okay, we developed B in the previous slide. Okay, so now if you transpose this, you will get this one. So you can represent this total equation in terms of Triset matrix. Okay, how you can represent? So this will be equal to, so this is the branch current. So IB, 1 minute, I will take another color. Okay, IB is equal to, so this is the B transpose, right? So B transpose into capital I. So this is the relationship between your branch current, Triset matrix, and link current. So you can call it as IL also, you can call, right? IL, right? So this is the relationship between Triset matrix and branch currents. Okay. See here. So the final equation we are getting IB is equal to B transpose into IL, and this IB is a column vector of branch current. B transpose is the transpose of your Triset matrix. Your Triset matrix is this one, B. Okay, if you transpose this, you are getting this. The IL is the vector of column vector of your all fundamental loop currents or link currents. Okay, so finally you are getting this equation. Okay, this is how you can establish the relationship between your branch current with the loop currents by using a Triset matrix. Okay, so with this Triset matrix is completed. So up to this, you are having any doubts? Up to this, you are having any doubts? See here, ma. First you will be given one electrical network. Okay, so from the electrical network, you have to draw the graph. So draw the graph. Right? How you can draw the graph? All the passive elements in the electrical networks are replaced by line segments. Voltage sources are short circuited and current sources are open circuited, so that you will get one graph. Okay. Now after getting the graph, from the graph you select one tree. Okay, so you will be having so many trees for a particular graph, but you select only one tree. So this selection will be arbitrary. Okay, arbitrarily you select one tree, right? So this tree is what is this tree? It will be having all nodes in the graph, but no closed loop. Okay, so you have to select some branches in the tree. So with some branches and all nodes, you form one tree. So which is having no closed loop. Now the removed elements are called the links. Okay, so removed elements are called the links. Now you are having how many links? Those many Triset loops will be there, or fundamental loops will be there. Okay, so after selecting the tree, first you have to identify the number of links, right? So how you can know? The removed elements are the links. With each link, you can form one fundamental loop. Okay, so you have to develop the fundamental loops, or you have to find the Trisets. Okay, so this Triset is having one link and remaining trees. Okay, so with each link, you will form one Triset. So that Triset is called the fundamental loops also. Okay, so you will get the fundamental loop. Now, after getting the fundamental loop, in each loop, you have to represent the currents I1, I2 like that, right? So each after representing the this loop currents I1, so the direction will be same as the link current. Okay, how you can represent this direction of loop current? So the direction of loop currents will be same as the direction of link currents. Okay. Okay, so then you develop the matrix B, right? So how you can develop this matrix B? So this B is equal to, so Bij, so you are having the elements Bij, and the Bij will be equal to +1 if the particular branch is there in the loop and the direction of the branch current will be same as the direction of loop current. It will be the -1 if the branch is there in the loop and if the direction of branch current is opposite to the loop current. Okay. And what is the order of this B? So which is a Triset matrix. The order of this B is L by B. So that means rows are represented with loop currents, right? Loop currents I1, I2, I3 like that. And columns are your branches 1, 2, 3 up to 6 or 7. So whatever may be the branches. Okay, so you can form the, and the value of this Bij will be 0 if your branch is not there within a loop. Now in the first loop you will be having certain branches, okay, and branch currents also will be there, right? If the branch is not there, so suppose if you take one branch, first branch, if it is not there in the first loop, the value is 0. So if the second branch is there in the loop and the direction of branch current is opposite to this I1, so then the value is -I1. So if the branch 3 is there in the loop, but the direction is in the same direction, you have to take +1. So like that, you will get the Triset matrix. Okay, and you have to remember the relations, these relations, which is a linear relationship between your branch currents and linked current. So this IB is equal to V transpose into IL. And if you want to represent with the voltages, then V into VB is equal to 0. Okay, so these equations you will get here in the Triset matrix. Okay, right now. So I think it is clear. Okay, next you are having Cutset matrix. Okay, so now this Cutset matrix we will discuss in the next class. It is already time over. So 3:59. Okay, I am stopping here. So please there in the online, I will take the attendance here. So this time only for, so many people are absent today. So number of participants is showing 40. So 40 minus 2 you have to take. So only 38 students are present out of 65. 38. So how many absentees will you get? Seventeen members are absent. 17 or 27? 27 members. Okay, man. Waiting the. So D1 is absent. D2 okay, D3 okay, D4, D5, D6, D7, D8, D9 okay. So E0 is absent. E1, E2, E3, E4. So E5 is absent, E6 absent, E7 also absent, E8, E9 absent, F0, F1 absent, F2 also absent, F3 okay, F4 absent, F5 okay, F6 absent, F7, F8, F9 absent, G0, G1, G2. So G3, G4 absent, G5, G6, G7, G8, G9 absent. H1, H2, H3, H4 are absent, H5, H6 okay, H7 absent, H8, H9 absent, J0, J0 absent, J1, J2 absent, J3, J4 absent, J5 absent, J7 absent, J8 absent, J9 absent, J0 okay, Q1, Q2 absent, Q3 absent, Q4 okay, Q5. So here below I'm having G8 present, H9 present, K3 present. So who is Sai Pranit Reddy now? D Sai Pranit Reddy. So what is his roll number? I already told you to rename your name with the roll number. So this Sai Pranit Reddy. What is your roll number? 1, 2, 3. Okay, I can leave.